Do you know the many surprising connections between the deepest parts of space and the deepest recesses of our ocean? Both are cold, dark places where humans cannot breathe and where the pressure alone is enough to kill you. Both upset our normal experiences of gravity, providing explorers with a strange weightlessness or buoyancy if they could somehow survive being there in the first place. And both contain many unsolved, captivating mysteries. Our oceans are filled with life we've never seen before. And who can say what lurks in the unexplored corners of space? I was initially caught off guard when I heard that NASA had turned its attention towards exploring the Hadal zones deep in the ocean. After all, NASA is normally all about space. What are they doing deep under the water and on Earth? I'm Alex McColgan, and you're watching Astronomy. Put on your diving gear and join me in a world of undersea facilities, uncanny life, and an environment so hostile that we've mapped more of Mars than of this terrain on our own planet. In 1957, a year before NASA was founded, a paper published in the Journal of the Royal Society of Arts claimed, "The deep oceans cover over 2/3 of the surface of the world, and yet more is known about the shape of the surface of the moon than is known about that of the bottom of the ocean." This was a reference to the fact that in the world before echo-sounding technology was commonly used to map the sea floor, we didn't know much about the topography of what was down there. We've come a long way since then. But while we have mapped the moon thanks to satellites and telescopes, we have still only mapped 23.4% of the ocean floor in high resolution. In fairness, this still represents an area of 120 million square kilometers, about 3 times the moon's surface area. So the old saying no longer holds entirely true, hence why we can instead talk of Mars, which has a surface area of 145 million square kilometers. But still, it's a profound gap in our knowledge of our own world. NASA was founded in 1958 with the purpose of expanding human knowledge of phenomena in the atmosphere and in outer space, and developing vehicles and technologies that would help them to do so. Exploring the ocean was not originally on their radar or sonar. However, in 1978, NASA began monitoring the ocean with their first dedicated oceanographic satellite, SeaSat, which was capable of collecting data on sea surface winds, surface temperatures, wave heights, and other features. This helped them learn more about our planet's oceans and their impact on the global climate. Still, some of NASA's most exciting forays into the ocean only began at the turn of the millennium. One way in which the sea can prepare astronauts for space is through simulated space experiences. About 7 kilometers off. Key Largo 35 in Florida is the world's only undersea research laboratory, Aquarius Reef Base. Built in 1986, it is a small, 3-roomed habitat large enough to house 6 people at a push, with a main room that combines sleeping and living quarters, an entry dock, and a wet porch for entering the sea around it. It was originally designed to help aquanauts remain at the bottom of the sea for weeks at a time through a technique known as saturation diving. By remaining at the depth of 19 mil, the human body becomes saturated with gas dissolved in its bloodstream, which allows these researchers to stay at depth without ill effects for much longer periods of time. 9 hours for one dive rather than 1 or 2 hours. This made it ideal for biologists wanting to study the local environment in situ. In 2001, however, NASA, along with other space agencies such as ESA, realized that it made for a great space training location. The cramped living conditions mimicked those found on the International Space Station. So astronauts who spent a week at Aquarius Reef Base would get a vital taster of what life would be like up there. It also allowed them to practice performing experiments and generally get used to the expected and unexpected aspects of life in a hostile environment. NASA began the NEMO program, or the NASA Extreme Environment Mission Operations, and that same year began sending their astronauts to the habitat. There have been 23 NEMO missions since then, merging astronaut crews from a variety of different space agencies, which lasted up to 3 weeks. Astronauts there became aquanauts and got the chance to don deep sea suits, getting a taste for what spacewalks might be like outside of our planet, readying them for the day humans return to the moon or go to Mars. This was not the only use NASA had for the ocean, however. Perhaps the most significant training was not for NASA's astronauts, but rather for the machines that would one day visit the largest oceans outside of planet Earth. Let's now go deeper and consider the exploration of alien oceans. Our solar system is home to many large oceans outside of Earth. Jupiter's moon Europa and Saturn's moon Enceladus, to name just two, have significant bodies of water beneath their kilometer-thick icy surfaces. In spite of being only 1/4 of the Earth's diameter, scientists believe that Europa holds twice as much water as all of our oceans combined. This is an intriguing concept, as even though no sunlight penetrates down to those depths, the mixture of liquid water bordering a rocky inner crust would make both of these locations ideal candidates for life. Scientists have considered how to best test to see if life really has arisen in the oceans of icy moons. In 2024, NASA will launch the Europa Clipper, with the mission to fly by the moon Europa and scan it to learn more about the depth of its icy shell, to try to determine the composition of its oceans and generally get a better picture of the moon as a whole. However, Europa Clipper will only be laying the groundwork for future missions, which one day might see cryobots melting through the 10-kilometer-thick icy shell of Europa using nuclear-powered radiators to penetrate its oceans and see firsthand what lies below. Once down there, no radio signal will be able to easily reach them. Messages will be relayed via a vast cable brought down through the ice along with the cryobot. This means that such cryobots will need to be able to autonomously descend a further 100 to 200 kilometers to explore the dark, chilling, and highly pressurized environment they're likely to find, to see what alien life might swim in those waters. So, with a mission objective on the horizon to explore deep, dark waters in search of never-before-seen life, what better place to start than the unexplored oceans we already have at home? The deepest parts of the oceans on Earth are only 11 kilometers deep, but due to the gravitational differences between Europa and Earth, the pressure you'd experience between the two are much more comparable than you might think. Europa's 100-kilometer deep ocean is thought to have a hydrostatic pressure between 130 to 260 AMP, which if it existed in an ocean on Earth would equate to a depth of around 13 to 26 km. This is much better than if you'd had to go hundreds of km down on Earth, but it's still no picnic. Pressure at the bottom of the Mariana Trench, the deepest place in our ocean, is 100 times the pressure on the surface, which is enough to crush the individual cells in the human body or to implode most submarines. And yet, life survives here. And it doesn't just survive, it thrives. The deep-sea explorers of the Galapagos hydrothermal expedition in 1977, using a specially reinforced remotely operated vehicle that could survive those pressures, were shocked to discover not a barren wasteland, but thriving ecosystems gathered around hydrothermal vents on the ocean floor down there. Tube worms, crabs, and fish were found in rich abundance. As scientists performed more dives, they found all manner of strange life forms down there. Shrimp-like amphipods the size of your hand. Giant, ethereal, big-fin squid that were 8 meters long and looked positively alien. In the depths between 6,000 and 11,000 kilometers, in an area known as the Hadal Zone, named after the god of the underworld Hades, life had learned to adapt to conditions in ways no one could have imagined possible. And this incredible adaptability gives scientists a better understanding of what might be possible on other worlds. The deepest parts of the ocean are mostly found near the fault lines of continental plates, where one plate subducts under another. These deep trenches create a unique V-shaped environment that channels organic debris from above down into a sludgy pool. Whenever a carcass falls down here, the organisms in the Hadal zone are somehow able to quickly detect it and arrive within minutes. Other organisms rely on the nutrient-rich liquids pumped out of thermal vents. If you added up all these trenches into one land mass, you would end up with an area the size of Australia, a whole unexplored continent. NASA wants to explore these regions using autonomous drones, perhaps whole swarms of them, that would be able to detect locations of interest such as thermal vents, and would be able to map out the terrain using cameras and onboard AI similar to that used by the Perseverance rover on Mars. It's a challenging task. Not only would such a drone need to be able to withstand the excessive pressure, but the temperature around such thermal vents can spike to hundreds of degrees. Drones would need to be able to survive rapid temperature swings if they are to survive. In 2014, one such deep-sea drone known as Nereus was sent into the Kermadec Trench off the coast of New Zealand. This is the area NASA has selected as a testing ground for its new equipment. However, sadly, Nereus was not able to survive the pressure down there, in spite of having succeeded on Hadal dives before, and it imploded. Pieces of plastic were later found floating to the surface. NASA's latest drone is Nereus's descendant, a smaller, lighter autonomous submarine known as Orpheus. Orpheus has yet to enter the depths of a Hadal zone. Instead, it is being put through its paces in shallower waters. But if it works, its lighter design would make it easier to transport on a rocket to the oceans of Europa at some point in the distant future. Although, this dream might not be so distant after all. In 2023, NASA's Planetary Exploration Science Technology Office, PESTO, gathered a team of 40 top researchers from multiple fields in the California Institute of Technology to discuss how close we might be to making this trip. A surprising amount of the technology needed is already there. Their conclusion was that the mission was feasible, scientifically compelling, and the most plausible near-term way to directly search for life in situ on an ocean world. With the combined information being gathered by Europa Clipper, and the technical experimentation being done with Orpheus and other autonomous submarines like it, perhaps it is something we will see within our lifetimes, although no concrete plans have been made yet. When it finally does happen, though, and a human-made drone starts to swim in those dark seas across the Gulf of space, what will it see? Perhaps it will feel strangely like home. We are water-based life forms here on Earth. The first large, complex animals formed in our oceans. All life is dependent on water to live. Rather than arid rocks and dusty wildernesses, there will be something strangely soothing about exploring oceans beyond our own, like entering a place we already know, even though we've never been there before. Does something lurk in those alien seas? Although it's only speculation, the sheer fact that this might be true is enough. To discover that life came to exist not once, but twice in just our own solar system would have massive implications on life's prevalence in the universe as a whole. It would mean life is likely abundant, and we ought to be ready to see a lot more of it out there. But proving it is the challenge. Only by perfecting the technology here on Earth will we be able to crack open those frozen shells, enter those inky depths, and find the definitive answers we seek. For NASA, their mission to find life in our solar system begins in our oceans. Outro update on the Patreon. We are now 84% of the way to our goal of 1,000 astronauts on Patreon, and I cannot thank you enough for having answered the call. The closer we get, the more it's looking like I'll be able to expand our content here and bring back Astrum answers, so submit your video suggestions and questions over on Patreon, and if you'd like to become an astronaut, you can join the Patreon with the link down below. Once again, a huge thank you from myself and the whole Astrum team. I'll see you next time. Meanwhile, click the link to this playlist for more Astrum content.